Inequality word problems. All right. We want to look at some important phrases. Now, these are not every phrase that you might see, but it's just some of the phrases that you might see. So, words that mean less than are fewer than, under, less than equal to, up to, which would include whatever number they gave you, at most, not more than, words that mean equal, which you've seen already, is, needs, has, is equal to, greater than, taller than, more than, older than. These are just examples now. You realize that there can be more than that. Greater than, equal to, or, something or more, at least, no fewer than. Now, these are just some phrases, just a little graphic organizer to help you remember those. Now, let's start with our first example. The members of a school booster club are creating buttons for sale at a basketball game. The machine to make the buttons costs $45. The material needed to make each button costs 20 cents. The buttons will be sold for $1 each. How many buttons must be sold to make a profit of at least $100? Now it says at least, so you know that you're going to be using greater than, equal to in your inequality. Now, I just wrote down the information that it gave us. The cost of the machine is $45. The material is 20 cents per button. So I put 0.20 for 20 cents. And then the button is sold for $1 each. And you want to know, you want to make at least $100 on selling these buttons. So let's go down, and our number of buttons, of course, that's important. We don't know how many buttons, so that's our variable. All right, here's our cost expression. It costs 20 cents to make each button, plus there's a flat rate of $45 for the machine. So you've got to recover that money. You've got to get that money back when you're selling. And profit is equal, it's going to be equal to what you sell something for minus the cost. So we're going to use our expression for that. We've got $1. That's the money that we're going to earn per button. So 1x, $1 per button. 1x minus this entire expression right here for the cost, which is 20 cents per button plus 45 greater than, equal to 100. So now we're going to distribute that minus sign throughout. That's going to change this to negative 0.20 and negative 45. Now, when I take 1 and I subtract 0.20, I get 0.80. So, and then minus 45 greater than, equal to 100. I'm going to move the 45 to the right side. I do that by adding. That's going to give me 145 on the right side. Then I'm going to divide by 0.8. And when I divide 145 by 0.8, that's going to give me 181.25 buttons. So I've got to sell 181.25 buttons in order to make $100. Now, you can't sell 0.25 of a button. You either sell the whole button or you don't sell a button at all. So I can't say 181, even though that's how we like to round things. We like to, because this is not 0.5, so we think we need to round down. But remember, you want to make $100. So 181 buttons is not going to make you $100. It's going to be less. So you have to say that you have to sell 182 buttons. You round that up because you want to make at least $100, and that's the only way you're going to do it. Because that 0.25, if you don't use that and round up, you will only make $99 and something. Okay. Let's go to the next question. The sum of a number and 9 is no more than 3 times the same number increased by 15. My number is x. So sum means to add. Why am I adding? Remember, this is a preposition. So the objects of the preposition, a little bit of English grammar here. The objects of the preposition is what I'm adding. So I'm adding a number and 9. So x plus 9 is no more than. It means that this is going to be less. Even though it says more than, it says no more than. So this is going to be less than or equal to 3 times the same number, 3x, increased by 15. Increased means to add. All right. Now, I'm going to solve the equation, and I move the variable to the right side because it keeps it positive. That's the only reason. So now I have 9 is less than or equal to 2x plus 15. In all honesty, you could have moved the 3x this way, but we didn't. All right? Now we're going to subtract 15, and 9 minus 15 is negative 6. And negative 6 is less than or equal to 2x. Then you divide by 2. That gives me negative 3 is less than or equal to x. Now, that doesn't help me with anything. I want my variable on the left, so I flip it around. And when I do, remember, you have to flip your inequality sign. So x is greater than or equal to negative 3. Any number bigger than negative 3 will solve this. There's infinitely many solutions because it says that it is no more than that. So there isn't just one number that works. It's any number bigger than negative 3. Greater than or equal to negative 3. All right, in a given rectangle, the length is 4x minus 5. And any time I have a word problem and it tells me that I have a shape, the first thing I do if they don't provide the shape is I draw the shape. So here's my rectangle here. The length is 4x minus 5. I label it. Here's my length, that's 4x minus 5. And the width is x plus 7. I labeled it. If the perimeter, and perimeter, remember, perimeter is equal to 2 times the length plus 2 times the width. If the perimeter is at most, that means it can't be any bigger than 44. Write an inequality that models the condition. Solve and state the largest dimensions of the figure. That does not mean these are the only dimensions of the figure. They're asking for the largest ones possible. So, we're going to add all these sides together because that's what perimeter is. So when we put them all together, that's 10x plus 4 is less than or equal to 44. Then we solve that expression. We subtract 4 from both sides. 10x is less than or equal to 40. Divide by 10. So x is less than or equal to 4. So 4 is the biggest number that you can have for x. Since it's the biggest number, because all other numbers would be less, since it's the biggest number, I'm going to write 4 in here. 4 times 11 minus 5. No. 4 times 4 minus 5 is 11. And 4 plus 7 is 11. Thank you.